the Foundation Tier Paper 1 Non-Calculator for June 2018. This is the AQA paper, okay? So first question, work out 1/2 times 5, okay? So the first thing that I would do is I would work this out, okay? So 1/2 times 5 is essentially 5 lots of 1/2, okay? So you could turn this around to make it look a bit nicer if you want, okay? So you imagine you have 5 halves, okay? Now, when you multiply fractions, you multiply the top, okay? So the numerator. So this will give us 5 halves, okay? Now the options that we're given 5/10, 2.5, 1/10, and 2 1/5, okay? So we have mixed fractions here, so these are both mixed fractions. So we can't compare them at the moment to what we've got. So we'll have to convert what we've got into a mixed fraction, okay? Now, when we do 5 divided by 2, we are saying how many times does 2 go into 5? Okay, so if we do our 2 times table, we get 2, 4, 6. Okay, so we've gone too far with the 6. So 2 goes into 5, 1, 2 whole times, okay? But then we have 1 left over because to get from 4 to 5, we have 1 more. So we have an answer of 2, remainder 1, okay? Now, because we're talking about halves, this remainder 1 is 1/2. So the answer is 2.5, okay? So that's what we get from 5 halves to 2.5. So then we can quite easily see that this is the correct answer. Okay, so next question. Circle the number that is 5 less than -2. So what that means is it means that we need to find the number in this list that you get when you take 5 from -2. Okay, so if we have -2 and we take away 5, essentially we're looking at a number line like this. Okay, let's say -2 is here. Okay, so -2 is here. This is the so this will be -1, and this is the positive direction, and then this is the negative direction. So this will be -3, -4, -5, -6, -7, and so on. Okay, so circle the number that is 5 less than -2. So we start on -2, and then we count backwards. Okay, because we're doing less than, so it's got to be a more negative number. So we go 1, 2, 3, 4, 5. Okay, so we've landed on -7. So -7 is our answer. Okay. So next one. Simplify 3 times a times 3 times a. Okay. So the important thing is what I like to do. I like to group the numbers together. So I'll do 3 times 3. And then I'll group the letters together as well, okay, and this just helps me separate in my mind what I'm going to do. So I'll do the numbers first, okay, so 3 times 3, that gives me 9, and then when we do a times a, we get a squared, okay, so that gives us a squared. So the answer is 9a squared. Okay, and next we have which shape is similar to shape X. Okay, now what similar means is it means that if you took the shape and you stretch it or make it bigger, all of the dimensions are bigger by the same proportion. Okay, so what that means is imagine you have a person and you make their arms 2 meters longer than they are at the moment, but you leave everything else the same. They're going to look a bit strange, okay? But if you took a person and made their arms 2 meters longer, but you made everything else about them larger by the same proportion, they wouldn't look so strange. I mean, they'd be pretty big, but they wouldn't look so strange, okay? Everything would be in proportion and sort of in the right ratios, okay? So that's what we're talking about when we talk about similar shapes. We're talking about a shape that's different, but it's similar in proportions, okay? So if we look at shape X, which is the one that we've been asked to compare the other shapes to, and then we compare it to shape A, we can see that shape A has grown in this dimension, this direction, but it has not grown in this direction. So it is not in the same proportions that shape X is. Okay. Now, if we look at B, we can see that it's grown, it's been stretched in this proportion, but not this way by the same amount. Okay, so that is not similar. So it's not this one, and it's not this one. Now, if we look at D, we can see that the arrowheads have been stretched, but these little bits haven't. Okay, so again, this is not similar. But if we look at C, we can see, well, it's been stretched in this dimension, okay, and it's been stretched in this dimension by what looks to be the same amount. Okay, so it looks more similar to X than the other shapes. So we can say that C is in fact the similar shape in this scenario. Okay. So next one. Work out 20% of 14,000. Okay, now the important thing here is what we have to see is we have to see, well, okay, what can I work out more easily than 20%? And the answer is I can work out 10% of 14,000. Okay, so if I work out 10% of what 14,000 is, and then I times it by 2, that'll give me what 20% is. Okay, so let's try that, shall we? So first we need to know, well, what's 100% of 14,000? And of course the answer is, well, it's just 14,000. Okay, because if you have 100% of something, it just means you have the whole thing. Okay, if you have 100% of a cake, you've just got one cake. Okay, so now that we know that 100% of 14,000 is 14,000, we can quite easily see that 10% is just 10 times smaller than 100%. So to get from 14,000 to whatever 10% of 14,000 is, we just divide by 10. Okay, and when we divide by 10, what we do is we essentially remove a 0 from a number. Okay, we just knock a 0 off. Essentially, that's the quick way to do it. So that gives us 1,400. Okay, and as I said before, to get to 20%, we need to times whatever 10% is by 2. Okay, so 20% of 14,000 is whatever 10% is, which is 1,400 times by 2. So 1,400 times by 2 is 1,400. Add 1,400. 0, 0, 0, 0, 0. 4 add 4 is 8. 1 add 1 is 2. So the answer is 2,800. Okay? Write 0.85 as a fraction in its simplest form. Okay, now the best way to think about this is, so you write out the number like this, 0.85, and then you identify the place value of each digit. So this is the units column, this is the tenths column, this is the hundredths column, and then what you do is you find the one that's furthest to the right, okay, the hundredths, you draw your fraction, and then you put this on the bottom. So the hundredths, the denominator becomes 100. And then what we do is we look at all the numbers that have been given. So we're going to have a 0, an 8, and a 5, and we can simply just write them on the top. Now obviously, if we have a 0, we don't really need to write it, so we can just write 8, 5 over 100. Okay, now this has been asked for in its simplest form, and the way that we do that is by dividing the top and the bottom by the highest common factor. Okay, now you can work out the highest common factor by writing the numbers down and then listing all of the factors that you can think of, but it's often quicker to just sort of look at the number and think, well, what number do I think would divide into both of those, okay? And I would look at this and say, well, since they both end with a 5 or a 0, I'm going to try 5, okay? So we find 5 as a potential factor, so we divide the top and bottom by 5, okay, to make it simpler. So 85 divided by 5 is going to be 17. 100 divided by 5, and that's going to be 20, okay? Now we look at this number and we say, well, can we simplify that any more? Well, 17 is a prime number, so no, we can't. Okay, so the answer is 17 out of 20. Okay? Now, the next one is write 5/8 as a decimal. Okay, now, the way to do this is to realise that an eighth is equal to 0.125. Okay, we could do with remembering that. Now, it's not a problem if you can't remember that, because what you could do is you could say, well, I know that a quarter is equal to 0.25. Okay, so to go from a quarter to an eighth, you have to divide by 2. Okay, so if you imagine you have a quarter and then you split that into an eighth, you'd have to cut that quarter in half. Okay, so to go from a quarter to an eighth, we've divided by 2. So if you divide 0.25 by 2, you get 0.125. Okay, so then if we have 1/8, we can work out 5/8 simply by timesing by 5. Okay, because 5/8 is just 1/8 5 times. So it's the same for the decimal. 0.125 times by 5 gives us 5/8. Okay, so 1/8 times by 5, so 0.125 times by 5 is equal to, what's that? So 25 times by 5, 0.625. Okay, so then our answer is going to be 0.625. Okay. Now, next thing. Okay, so a rectangular carpet measures 8 meters by 6 meters. Part of the carpet is covered by a square rug of length 2 meters. Okay, so what we can do, so we have to show that 1/12 of the carpet is covered by the rug. Okay, so the first thing that I would do is I'd say, well, I've been given the measurements of the carpet, 8 meters by 6 meters. Okay, so I can work out the area of the carpet, which is 8 times by 6, which is equal to 48 meters squared. And I've been told that the carpet is covered by a square rug of length 2. Okay, so the area of the rug is going to be 2 times 2. Okay, it's a square, so it'll be 2's on each side. 4 meters squared. Okay, so I know that this is 4 meters squared. I know that all of this is 48 meters squared. Okay, so show that 1/12 of the carpet is covered by the rug. So I need to show that this area here is 1/12 of this area here. Okay, so when you have to show that one quantity is a fraction of another, you simply do the smaller one divided by the larger one. Okay, so we have 4 out of 48 meters squared. So we have expressed the area of the rug as a fraction of the area of the whole carpet. Okay, so that gives us, so again, if we try and simplify this down, we can find the highest common factor. Okay, so in this case, the highest common factor is 4. Okay, so we divide the top and bottom by this highest common factor. So 4 divided by 4 gives us 1. 48 divided by 4 gives us 12. Okay, so we've shown that 1/12 of the carpet is covered by the rug. Okay. So the next one. So Sam, Carl and Eric share 40 sweets. Eric gets the largest share. What is the smallest possible number of sweets that Eric could get? So essentially, we've been asked, or we've been told, that Eric gets the largest share, but he doesn't get too many. Okay, so I think the idea here is that they share the sweets out, but there's not quite enough that everyone gets the same amount. So they're going to try and make it as fair as possible by making sure that Eric has the smallest possible number of extra sweets that he can. Okay. So what I would say is that I would say, well, let's say that they all share them evenly, or as evenly as possible. What would we get? Okay, so we've got Sam, Carl, and Eric. So there's 3 people. Okay, so 3 people share 40 sweets. Okay, so this can be figured out by doing 40 divided by 3. Okay, so divide 40 sweets equally by between 3 people. Okay, so 40 divided by 3, we do our 3 times table. We get to 30, which is 10 sweets each. And then we get to 33, which would be 11. We get to 36, which would be 12. 39, which would be 13, and then we've got 1 left over. Okay, so the answer would be 39. Oh, sorry, not 39. It'd be 13. 13 remainder 1. Okay, now that means that Sam, Carl, and Eric have 13 sweets each. 13, 13, 13. Okay, so in total between them they've got 39. Okay, so we have 1 left over, remainder 1. This 1 sweet that's left over. So what do we do with it? Well, we look back at the question. We say, well, Eric gets the largest share, okay, but he gets the smallest possible number of sweets. Okay, so to get the largest share, Eric has to have this extra 1, doesn't he? So 13 plus the 1 that's left over is equal to 14. Okay, so Eric has 14 sweets, and that's the smallest number that he can possibly get whilst also having the largest share. Okay. So the next one, the time in Rio is 3 hours behind London. The time in New York is 5 hours behind London. What is the time in New York when it is 1 a.m. in Rio? Okay, now the best way to do these questions is to write down the information. Okay, so Rio, just to help get it straight in your head. So what is the time in New York when it is 1 a.m. in Rio? So Rio, it's 1 a.m. Okay. Now, what is the time in New York? Well, we don't directly have a relationship between Rio and New York on the information that we've been given here. Okay, we only have a direct relationship between Rio and London. So I'm going to write down London next. So London, okay. And we're told that the time in Rio is 3 hours behind London. So that means that London is 3 hours ahead, okay. So that means we need to add on 3 hours to go from Rio to London, which gives us 4 a.m. Okay, so we know the time in London now. Now, the time in New York, which is what we've been asked, is 5 hours behind London. Okay, so I'm going to write New York. So it's 5 hours behind London. So it's minus 5 hours. Okay, so 4 a.m. minus 5 hours. We go back 1 to 3 a.m., 2 a.m., 1 a.m., 12, and 11 p.m. Okay, that's 5 hours. So we need to understand how the clock works here. So we have a clock like this. We've got 12, 1. This is going to be a terribly drawn clock. I'm sorry. 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so at the moment we're on 4 a.m. in London. So we are here. Okay, then we go 5 hours back. So we go to 3, 2, 1, 12, 11. Okay, now we were in AM here. This was all AM. But because we've gone back past the 12, this is all now PM. So it's 11 PM. Okay, that's the answer.